Welcome friends to this series of learning AWS, and in this particular video we will come across Amazon's relational database service, which is offered by AWS for the relational databases. So we will explore what exactly the different AWS RDS database services are and how we can create them. So this video is going to be very interesting one because we will go deep into RDS and we will try to cover most of the things, how we can create the RDS database in AWS environment. So in this particular video, we will mainly focus on RDS MySQL database. We will not go deep into Aurora and all those things. But in the upcoming lecture, we will slowly go deep down Aurora. But before understanding or having the deep knowledge on Aurora, you should have some information with Amazon RDS database for MySQL or PostgreSQL. And this video is focusing on that. And mainly, those are the beginners and those are very much expert on RDS. This video will be helpful for both of them. So please be focused and check how Amazon relational database service can be created in AWS environment. So without wasting any time, let's get started. So in this particular page, you can probably see we are on awsamazon.com/RDS, and we are on this RDS document page. So why actually Amazon RDS database we use and what exactly is being offered in RDS. So this is very important. So RDS, as the name stands for, Amazon Relational Database Service, Amazon RDS. So it's a easy to manage relational database service, optimized for total cost of ownership. So it's a very basic of cloud that cost of ownership. You no need to own the entire database, rather you can pay as you are using it. So it's a very simple to set up, operate, and scale with demand. Amazon RDS automates undifferentiated database management tasks such as provisioning, configuring, backup, patching, etc. So we are going to use this RDS service with these open source database. So somebody can ask like why, ultimately we are going to create a MySQL database or PostgreSQL database. So basically these are open source database. We can definitely create them in our own environment on the on-premises system. So there the cost of ownership comes to the picture. Why should I pay the entire infrastructure for running this database, whether we are having these kind of services like Amazon RDS or Google Cloud SQL or Azure SQL, where we can actually pay whatever we use. And for that, we should not pay for the entire infrastructure. So this Amazon RDS is a managed, you can say managed MySQL MariaDB or DB2 or Oracle services. So basically, we are going to have the different databases created, but under the hood of AWS infrastructure. So we will come details like what are the multi-AZ and how this flexibility comes into the play. So don't worry about that. All these jargons you no need to put efforts to understand. In this particular video, we will cover as much as possible. But let me show you the benefits of Amazon RDS, which is basically offered by Amazon. So first and foremost, choice is basically easy to manage because you just fill the form and you can directly use the database either privately or publicly, and you no need to bother about the underlying infrastructure and to maintain the software. Okay, you just specify the engine version and that's it. And this is a choice of engines because you can have the variety of choices of engines you can practically use. So basically, the good point in RDS that it is offering many open source and enterprise databases. So I mean, it's just compared to Google Cloud SQL, you are having limited to MySQL or PostgreSQL and SQL Server. Over here, you are having extra choices like, DB2, IBM DB2 recently added. So you can easily use this RDS database even for creating an Oracle database. So in Google Cloud SQL, you cannot create a DB2 Oracle databases. Those are enterprise databases widely used in industries. So in RDS, you can easily lift and shift and create them to RDS. High availability definitely is the benefit of RDS. You don't need to bother about to set up all these environments for the standby or the replicas. You just have these highly available and database within a minute or so. I will cover most of them in this particular video. So in the subsequent lecture, we can definitely go deep into each of them because it's a very interesting thing, and this series is going to be very interesting where we are going to discuss about different AWS databases. And these lectures will be helpful for the data engineers and the database administrators in industries. So this is the Amazon RDS, and as I said, right, I mean, PostgreSQL, MySQL, MariaDB, SQL 7, Oracle, and DB2. So variety of database engines, including the most popular open source ones and industry standards, enterprise databases, all main databases are being um, covered through RDS. So you can have a different lift and shift things you can do with on-demand prices. So there are lots of things, and you can see that lots of customers are happy with Amazon RDS databases. I am not going deep into all these things, but at least we are having the basic idea before we are going to create the RDS database. That why should we create our RDS database as a managed database, relational managed database service offered by Amazon, right? So now let's go to our console. So I'm just closing this other tab, and over here actually I click this overview and features link where actually I landed up that particular page. So basically, this is the um, dashboard of our Amazon RDS, and we are on dashboard. Basically, we can create the DB instances over here. Once we click these DB instances, it is going to say that I am having no database instance right now. So what I need to do, I need to create the database in front of you so that I can show you what are the different things are there. So you can see, I mean, it's just a few lines of things. So basically, first and foremost things, there are two options. One is standard create and one is easy create. So if you just click easy create, automatically it will provide the configuration, whatever is needed for best practice basis. Now it's for easy creation. I mean, you not have different choices to provide the details. It's a very limited kind of things you can provide. So I'm not going with easy create because easy create is something if you don't know the background of database and if you are having no database resources in your team, you need to create a database. So it's just the easy create will help you to select everything automatically. So this video is actually focusing for the people who are actually interested to know about databases. So standard create is the good choice over here. Now we are having number of choices for the database engine. Okay, so we are having Aurora. So Aurora is also RDS database on top of MySQL and PostgreSQL, but this is more managed ones. Like, I mean, you are having more features, a little bit expensive, but you are having more features on top of MySQL and PostgreSQL normal RDS database. So I will definitely come across and I will create videos on Aurora MySQL and Aurora PostgreSQL compatible databases dedicated for that. There are a number of features. We will come one by one what exactly these Aurora databases are and where these Aurora databases will be beneficial for us, and what are the use cases where we can use these Aurora databases, right? But this particular video, I am focusing on this one, MySQL or MariaDB. So this MySQL MariaDB databases are the open source database, and this is the most popular open source database in the world. And MySQL on RDS offers the rich features of the MySQL Community Edition with the flexibility of easily scale compute resources or storage capacity for your database. And one thing you need to notice, like it can scale up to 64 terabytes. Okay. Beyond that, if you are having one database which is going to be size like more than 64 terabytes, then these options are not suitable for you. Maybe you can choose some other database type like Aurora, which supports up to 128 terabytes of SSD storage. So, and it is also way faster than normal MySQL or PostgreSQL databases. All right. So this is this particular video will be focusing on MySQL because this is the must video that you need to watch before you move forward on Aurora. This is the first video we are publishing in this particular series. So we should focus on MySQL to understand what exactly goes on under the hood, and then we'll slowly go into Aurora. So fine. Our use case is very limited. Like we want to create some database which is less than 64 terabytes, and 64 terabytes is quite large. Basically, I mean, if you are having the experience in industry, you can see like data warehouses even in DB2 or Oracle. You can see maximum 16 terabytes or 20 terabytes, and most of the cases in most of the industries, e-commerce and other healthcare sectors, you can see these databases are maximum 16 to 20 terabytes in size. But if you go to telecom sector, maybe you can have petabyte scale of data warehouses or databases. So these are the transactional database, and we want some database which is practically going to be used in OLTP systems rather than OLAP. So the normal transaction systems we are going to create. So we have chosen this MySQL RDS database. So what we did, we just click standard create and we selected this MySQL database. Now let me move forward. So this is the MySQL Community Edition. Definitely we have not chosen my Aurora database. Now these filters are basically show only the versions that supports multi-AZDB cluster. And if you just because see, I mean, this engine MySQL 8.0.39 having the different flavors, like I can create production database, dev database, or free tier database. But if I just click on multi-AZ, show me the multi-AZ database cluster, you cannot create the free tier. Even I cannot click it. Okay. So no, I mean, if I really want to click, then I need to so for if I create this, if I choose this free tier, then I mean I just filtered the multi-AZ support clusters, then you can see I don't have any options because it automatically selected this single DB instance, okay, and that is not supported for multi-AZ. So the free tier basically can be used to create a single DB instances. It will not be able to create a multi-AZ DB cluster where you can really have the flavor of, create the standby replica of the primary database. All right. So over here, I can only use these limited options. Okay. So instead of doing that, let me select the dev test. Okay, where I can have the mixed flavor, like I can create multi-AZDB cluster or single DB cluster. Okay. So let me stick with dev test. Now Uh, Under the availability and durability, you can notice like, you are having different flavors like multi-AZDB cluster and multi-AZDB instance. Okay. So there's a little bit confusion. Like, both are multi-AZ. So what are the difference between them? So the cluster is basically, it creates a DB cluster with a primary DB instance and two readable standby DB instance. So in this option, multi-EV DB cluster, your standby database can be readable. Okay, so these standby databases can be used as standby as well as they can be used as read replica. All right. So here, each DB instance in different AZ, you are going to create the readable standby DB instance. So when you are using this cluster, you are having one primary DB and you will have two readable standby DB instance. But if you choose this multi-AZ DB instance, then you will have one primary database and you will have a standby database in a different AZ. But you cannot use your standby database for the read workload, so that your standby database cannot be used as read replica. You cannot connect to your standby database to read the data from the standby database. So standby database will be purely for high availability. Now, for different options, your cost is going to be different definitely. So the higher price is for multi-AZ DB cluster. Definitely, your standby replicas are also the read replicas for your cluster. But for the multi-AZ DB instance, you don't have any read replica. Rather, you can have the primary and standby DB instances. So it will guarantee you for the high availability and the data redundancy, but the standby DB instance doesn't support the connections for read workload. You can not connect to the standby database to read the data from your database. But if you choose multi-AZDB cluster, definitely you can go ahead and do that. You can connect to the standby and read the data from there. And definitely single DB instance is just a single DB instance. It will not have any read replica or standby DB instances. So for now, I'm going to select this multi-AZ DB instance so that we will have one primary instance and one standby instance, and we will not able to connect to the standby instance for reading the database. But that's absolutely fine. For the database instance identifier, we can name the database instance identifier as sample, and the sample database will be created. Now you can notice that the username, the root user, is going to be admin. All right, so you can change the name to root, or you can keep it simply as admin. Okay, so I prefer to keep it as root because normally the root is the user with which MySQL database instance actually being created. So I just kept it as root for the consistency purpose, nothing else. So now you are having this credential management. Okay, so either your credential will be managed by AWS Secret Manager, and this option is basically most secured one. So what RDS will do, RDS will generate a password for you, and it will be managed uh, throughout its life cycle using this AWS Secret Manager. So if you don't know what exactly the AWS Secret Manager is, so AWS Secret Manager actually stores the password and the user ID for a given application. So here the RDS will use this AWS Secret Manager. The other one, which I will actually use, that is the self-managed. So over here, I am going to provide the password in this particular form itself. So what are the password I'm going to set for root? I will need to provide over here. So I can say the root password is PASSW0RD. If I do so, it says that I cannot use because it's just minimum requirement that you need to follow. Like, you uh, need to have at least 8 printable ASCII characters, can't contain any of the following symbol like slash, at the rate, etc., etc. So you need to specify like how I should move forward. Okay. So let me give some kind of strong password in this particular case. So let me say, all right. So it is actually helping you how strong your password is. All right. So now I am going to use, now the next comes here is the instance configuration. Now, what kind of DB instance class I'm going to uh, select to host my database? All right. So there are three kinds of class are there. One is standard class, memory optimized class, and burstable class. Now, if you choose burstable class, then you will have these T3 micro and all these machines where you can actually have these burstable options. So whenever you are having some less memory or CPU utilized, you can use them when you will need some spikes. So those costs will be covered. Little bit burst whenever you are going to say like I need two vCPU and 1 GB of RAM. And for now, for maybe for entire during 12 hours or 14 hours, you did not use two vCPU and 1 GB of RAM, then those credits are going to be stored in your account. And whenever there is a spike is needed, when you need this 3 vCPU or 2 GB of RAM, you can redeem your points from that burstable class so that those minimum spikes could be covered within the limit. You don't need to pay extra for that. But if you are not satisfied with your burstable classes instances, maybe you can go for standard class. You can see it is going to be started with M7G large, which is basically having 2 vCPU, 8 GB of RAM, and having massive network speed as well. And this actually supports the Amazon RDS optimized writes. So you will have more IOs for these instances. For memory optimized instance are having more memory as it suggests, like 2 vCPU and 16 GB of RAM is the minimum one, and it can go beyond like DB, which having 128 vCPU and 4 terabytes of RAM, having 80,000 megabytes per second network speed, and the storage will be 3.7 terabyte with this NVMe SSD. So that's a robust system that you are going to have. For now, I'm fine with the burstable instance, which is DB-T3 micro, because this demo purpose, I can create a small database, and I mean for this DB-T3 micro is well beyond that. All right. So next, after you choose the instance configuration, you provided the what kind of machine I need to host the database. The next is coming the storage. So what kind of storage you need to provide to your database? So there are a couple of options. Okay. So one is general purpose SSD, and one is provisioned IOPS SSD, and the other one is normal magnetic tape. So this is the hard disk HDD, and it cannot go beyond 1000 IOPS, and it is really not recommended. I don't know why still magnetic option is still there. Definitely for cost effective, but anyway, you are going to create a database after all. So database should be should have more IOPS with you, and I mean it's definitely not recommended in any way for any kind of database. But anyway, I mean, if you are really worried about your cost, you just need the database having very few reads and writes. Maybe in that particular use case, I can think of you can use this magnetic tape. Otherwise, you can, I mean, it's magnetic disk, not tape anyway. But for other cases, you can use this general purpose SSD GP2 or GP3 version. So GP2 is the earlier version, GP3 is the next generation version. So the only performance matters, like, I mean, this baseline performance determined by volume size, and here also, but performance scales independently for the storage. So what does that mean? If I create the GP2 instance, and if I say 200 GB of space I need, then whatever the IOPS it will give, if I just increase the size like 2000 or say maybe 300, definitely at that case, the IOPS will be increased accordingly. So for the case of GP3, actually it doesn't matter how much storage you are actually using. So the performance does not scale with the capacity of the storage, right? If I keep 20 GB, the same IOPS will be provided as we are going to keep 200 GB. The same IOPS I will get. So GP3 and GP2 are this only difference between them. So definitely we should go with GP2 because I mean, if we increase the storage size, our performance will be increased accordingly. And I am fine with 20 GB of storage. All right. So other SSDs are provisioned IOPS SSD, and there are also two versions. One is IO1 generation and IO2 generation. So here actually uh, you are going to provide the IOPS, like, how much IOPS I need for our database purpose. So here I am not going to specify uh, that. I mean, this particular IOPS I actually need, and over here I am like, I mean, we can provide like allocated storage that is 100 GB to 6 terabytes, and this actually we are going to provide over here to specify the provisioned IOPS. Here, I mean, unlike GP2, where actually we are not going to provide this IOPS, like, I mean, whatever the IOPS I do need, here actually I need to provide the IOPS as well. It doesn't matter what is our storage size, at the same times we are going to provide the IOPS. So it will guarantee like these IOPS will be maintained for this particular storage. Now, if I choose this next generation of provisioned IOPS. So here actually it is better than version 1 or generation 1, which is offering the low latency, high durability, IO intensive storage. So if we really need this IO intensive storage, we can choose this IO2. Definitely the cost will be higher, and you need to provide the IOPS that you really need. So these IOPS also you need to provide like how much IOPS I really need. So your actual IOPS might vary from the amount that you provisions based your database workload and instance type, but this is the IOPS that you are actually asking AWS to provide you for this particular database to maintain the performance. So for me, I am really stick with GP2, where I am just providing this allocated storage. I need this 20 GB, and whatever the IOPS is going to be um, provide for 20 GB of database, I am fine with that. Definitely, I am not going to provide the IOPS, so it will be um, automatically given by AWS. Now, provisioning less than 100 gigs of general purpose SSD storage for high throughput workloads could result in higher latencies upon exhaustion of the initial SSD IO credit balance. What does that mean? If I actually choose this GP2 and 20 GB of space, and if I think that there is one IO intensive workload I am going to have, and at that moment what it will, I mean, whether uh, it can really serve my purpose. I mean, because I don't have IO intensive disk with me, so I am having the general purpose SSD GP2 instance, GP2 SSD disk. So how I can survive with the IO intensive workload? So there the burstable credit that comes into the play. So if, for example, I ran my database for a month or so, I did not have any IO intensive workload, and I have some credit remaining with me. Like, I mean, I did not, whatever the IOPS will be provided for me for 20 GB of instance, I did not use that. So those credits will be saved in my account, and whenever I will have one IO intensive workload, I no need to change my SSD to IO intensive one. Rather, I can stick with my general purpose SSD device itself, disk itself, and I can use the same disk for the IO intensive workload, because I have some credit left as I ran this particular database for a month without putting any IO intensive workload. So I have some credit, I can use that during the burstable time. But if that burstable credit got exhausted, then I will face these latency issues. So maybe I need to change my disk to maybe IO1 or IO2, whatever. So I need to provide the required provision uh, IOPS, and then I will go ahead with my intensive workload. All right. So I'm not putting much time over there. So I think you are having this idea like what exactly these four options are, actually the five options, and what exactly we need to choose for our business requirement. All right. So GP2 is widely used, and GP3 next coming to the picture. So GP3 is also used, but few IO intensive workloads we can use these IOPS, IO1, and IO2 disks as well, right? Now, next coming the auto scaling. So, you need to specify whether I need the auto scaling or not. Okay. So, it will start with 20 GB of disk, but what will happen if my 20 GB got exhausted? So, if you enable this one, it will automatically scale, and there would be some maximum storage threshold. So, it will go till 1 TB, and then it will stop adding the space. So it will be just stopped over there. So you need to specify some maximum storage threshold, and you can see it can go till 6 TB. So allocated storage volume must be 22 GB to 6 TB. So basically, this is the limit that you can set when you have enabled this auto scaling option. All right. So I'm fine with having this auto scaling on. So as my database disk size will go on increased, I will get more IOPS. I mean, definitely, there is no direct information is provided by AWS on that, but this is depending upon your current disk size, your IOPS will be depending upon that. Now, the next section, it talks about the connectivity. Now, for the connectivity, you either create a EC2 instance along with your RDS database, or you can connect the RDS database without having any EC2 instance with you. So it is just provide you the options whether you want to create one EC2 instance along with your RDS database to connect to the database privately. All right. And this network type is basically saying that whether your RDS database will only need IPv4 address, or you need both of them, like IPv4 and IPv6, or both. Okay, so dual stack mode is something like that. So I'm going to stick with IPv4. I don't want this IPv6 to be created. And I am having this VPC, default VPC created for me for IPv4 addresses only. So I am stick with this VPC. So it is recommended to create a new VPC and create your database inside that, so that you will have better security control. You can create your database definitely in a specific private VPC, and your applications can connect to the database privately in that particular VPC. All right. You need to create the subnet group. Okay. So in the default VPC, you should have some subnet group where you are going to uh, create all your replicas and databases. Okay, so this subnet group will be like, whatever the subnets you are going to uh, use for your database. For example, this particular database will be created in which region, and based on that, your subnet will be chosen. For example, I did not create any subnet group. So what it will do, it will create a subnet group for me. And this default subnet group will be used to host database. So if I need this database to be created, for example, I have selected this default VPC. It is having 6 subnets and 6 availability zones. Definitely for each availability zones, 1 subnets are there. And if I create a subnet group where these maybe if here, for example, say 3 subnets I need to be uh, used to span my database across 3 availability zone, then I will create a subnet group with 3 availability zone and use that subnet group during creation of this database instance. All right. So this particular VPC, if you see, this particular VPC is having 6 subnets and 6 availability zone. And this default subnet group will also have these, all the 6 subnets will be listed over there. All right. So if I go to VPC, you can see this default VPC, how it looks like. And from there, we will see like how the subnet group is created. So if I go to VPC, I can see this particular VPC is actually spanning across 6 subnets, and you can see US East 1B, 1A, B, C, D, E, F. So 6 subnets are there. And this particular subnet, if you check the subnet groups, you can definitely see that all these subnet groups are actually so if I go to the subnet group link under this Amazon RDS, you can see there is no subnet group is created, and this subnet group will be created. The default subnet group will be created, which defines a which will use all these 6 subnets. Those are actually under this VPC will be listed over there. So we will check after creation of this RDS database, we will create how the subnet group will look like. Default service, default subnet group will look. All right. So this is very important part that we have discussed right now. So if we really want to create a private database, for example, a database that should not use any public subnet. For example, over here, if we see that we are having 1A, B, C, D, E, F, 6 subnets are there in this particular VPC, and we want to know like, and all they are actually mapped with this particular route table, and I believe that all these are actually uh, the public one. So maybe we can check the root table over here, and this root table I think we can see it over here. What are the root tables? So if I click this root table, it is C696. If I go to root tables, C696, one root table is there, and we can see the roots like it is saying that the destination is anywhere in the world, and it is going to use this internet gateway. So if I click this internet gateway, I can see that it is actually solving the internet VPC IP ID attached with this particular VPC. So all these subnets are going to use the public database. So I mean, all these subnets are basically are public subnets. So actually, we don't create such kind of network for our databases. We generally create the private databases, private subnets. Those are not attached with any internet gateway through the route table. And those we create the database subnet group on only those private subnets so that it can span only to the private zones. It will not go beyond that. It cannot use this kind of public subnets. So this is how we actually secure our database. But for now, as it's a demo purpose, I am fine with the public access of this particular database. And really, I will click this yes button for I can use this RDS database can be accessed from the outside world. But for production purpose or for security purpose, we keep this public access low so that RDS can't have any public IP address assigned with this. So it will only have this private IP. All right. So next is security group. Now here again, we don't have any security group. I just want RDS to create one security group for us. Now this particular security group will be named as a default. So this is an existing security group that is going to be used. So if we check what exactly the security group is, let me go to this VPC dashboard over here. And if we check the security group, we can see the default security group is there. And this is the default security group. And this default security group is having the inbound access like all protocol, all tribe. All right. So I can edit this one and I can see like what exactly is this. So it is saying that this security group is actually in allowing all the access from this particular security group. So now this security group is 53AB. So 53AB is this security group. So this security group is actually allowing all these access. All right. So it is just having all access. So this particular default security group is going to be added over here. But for production databases or where we are having these more secure database to be created, we actually create the security group having limited access to those networks. Those are actually needed to be used for the application to connect to the database privately. For example, if I want an application like my app, which only can connect to the database, but there is other app like my app B, which cannot connect to the database. So there actually I restrict the access for my app to this security group. All right. So on that particular case, the IP address that is being used by my app application, we will allow only that particular IP range to connect to these particular database. And that can be done through security group. So here actually we are going to use the existing security group, and the existing security group is default. We can definitely create a new security group for us, but for now it's fine. If I click create one, then I need to specify like the VPC security group name, and that will be created for us. So for now, let me choose the existing one. And here it is specifying that whether I need to create any RDS proxy, and these RDS proxies will automatically create an IAM role and a secret manager for these RDS proxy. So RDS proxy is actually be used to connect to the database securely to this proxy. All right. So it is a fully managed and highly available database proxy that improves the application scalability, resiliency, and security of all. So if you click this info button, you can get all the details. I will have a dedicated lecture for this RDS proxy as well. But here is a brief introduction like what exactly the RDS proxy is. So you will be actually using the database pool for the connection. So the RDS proxy will allow the database or the applications to use a pool of connections. Okay. So this pool of connections is basically will help your database not to be congested with your uh, connection. So here this pool is already available for the application to use this particular pool of connections to connect to your database. And this will actually simplifies your connection management, and it will be more resilient for the database failure. Whenever, I mean, there is no, RDS will actually assure you for not be bombarded with a massive amount of incoming database connections. Rather, it will create the pool, it will manage the pool, and through this RDS proxy, you can efficiently connect your database without bombarding with connections. So I will go deep into RDS proxy in subsequent lectures, but this is what the RDS proxy in a nutshell. So if you check this box, it will create the RDS proxy for you. Now, certificate authority, these are all default and optional. If you don't select the certificate authority, RDS choose anyone for you. And using this server certificate, this is an extra layer of security that the connection, whatever you are going to make to RDS database, and this database connection will use this certificate. If you click this additional configuration, here you can mention the database port. Now, as it is a MySQL database, the default database port is 3306, but definitely you can change, and this anyway, it is going to be a TCP port itself. So the TCP port, you need to specify what are the port you can use that will be used to connect to the database. For now, I'm fine with 3306, which is the default one. Now, here you are having the options to provide the tags. Okay. Now, I'm not interested to provide the tags, but this is a very important one in the industry, like how you can recognize your database, like whether it's a production database or development database or test database. I mean, what kind of data you have over here, you can tag it accordingly. And it is very important to search your data through this catalog. I mean, you can use these tags for a cataloging purpose for the business requirement. So basically, if you are having the data architect in your team who actually build the tags for identify the data and identify the purpose of the data through these tagging. So it's very important. I'm not using it anyway, but it's a key value here. You can tag anything like production or sensitive information or something like that. All right. So next is database authentication. Now we can have three kind of authentication mechanisms. One is password authentication that we are going to use. We have provided this admin as root, and we have provided password as root 123456. So those password authentication will be used to connect to the database. Other option is that password and IAM database authentication. So you can either use password or IAM role and user. So those can be used to connect to the database. So I will have a dedicated video for these IAM users, but for now I'm fine with password authentication. And next one is password and Kerberos authentication. So Kerberos authentication is the other mechanisms where we can use the authentication from the Kerberos so that the password will be supplied along with the Kerberos. So I mean, three kinds of authentication mechanisms are there, which is supported by AWS. Now, for monitoring, normal monitoring will be there. I mean, if you don't click this enable enhanced monitoring, default monitoring will be there, but it will not have the granularity like 60 seconds. Okay. So even you can have this 1 second granularity with enhanced monitoring. So every second, it will capture the MySQL database, whatever you are going to create to RDS, and it will be published to CloudWatch log. So this CloudWatch will have your MySQL metrics data, whatever the granularity you are going to set. So now, if you are having 1 second of granularity, that means each second you will have the logs and you will be charged with more logs in the cloud storage for storing your CloudWatch logs. But if you having less granularity, then less logs will be captured and you will be charged less for storing the logs in CloudWatch. Now, it depends upon you. Even you can completely disable this enhanced monitoring, and you no need to have, for example, for the QA or test databases, you no need to have to capture all the details for enhanced monitoring. You can completely skip this thing and you have the limited data in your CloudWatch without having this kind of micro granularity of log monitoring. In the additional configuration section, you can provide the initial database name. I can provide the name as testDB. So what it will do, it will create the database for us along with the database instance. So testDB database will be created along with our database instance sample. Here, two things are there. One is DB parameter group and other is the option group. Now, what are they? If you click this option, you can see that the DB parameter group is the database configuration parameter. So whatever the database configurations are there inside RDS, you will have, you can configure them through this database parameter group. So over here, you can see one option is there for the parameter group. So if you click this parameter group, and you can see this parameter group has been created like the default parameter group. So here, this default parameter group, and you can see this default parameter group default.mysql 8.0, which is basically this one. So if you click this one, you can see that the parameters, whatever the parameters, 553 parameters are there. So these parameters are having some kind of values already set. All right. So you have the options to create your own custom parameter group. And from here, you can maybe check this one and you can see if you create a default parameter group for your database, you can use that parameter group over here so that you can change one custom parameter. For example, I will have like 553 parameters. I can copy this one and I can say, for example, I just don't want to auto generate certificates. Okay. And here, it has no value, but maybe I can keep it as false or something like that. All right. So that particular parameter group I can create where I am having the custom settings of these configurations, and I can use that particular DB parameter over here. Option group is basically the database option group that enables the optional functionality that you want to have in your database instance to support, such as Oracle or SQL Server data encryption, or maybe MySQL Memcache support. So all these extra extension that you are going to install in your database, you can have same thing. Like, I mean, just like the parameter group, you are having the options group for the extra features that you are going to install on your database. So for example, I am having these settings like, MySQL, default MySQL 8.0. So if I go to this option group, and this is the one that it is going to be used right now, and you are having nothing in this particular options, but you can associate some kind of options over here. So I cannot definitely click these add options. But if you create the custom one, and you can create a custom one, and there you can choose like MySQL, and you can having the major engine versions, for example, 8. And if I just have like name like MyDB, and if I create this one, I need to provide some description. If I click the create one, I can go over there and I can definitely add the options, like what are the options I need to uh, provide for my uh, database to use. For example, these kind of things, like, I can have the server audit, or I can have the server audit exclusion users. So those features I can use for my database to use. So all these extra things like MariaDB, it's a MariaDB plugin, or memcached. For example, memcached, I just need these memcached features with me, so I can add this option. And this memcached I can use definitely for my database. So I cannot actually use right now. I need to completely refresh this page to use the new option group that we have created. Okay. So if we choose this particular newly created option group, I can use P. Now, the next option is coming as backup. So it is having the enable automated backup. So I can create a point in time snapshot of my database. So if I enable the automatic backups, it will automatically create the backups, and I can set the retention period, like, 7 days or 1 day, 2 days, or whatever. So in that way, I can use the backup, automatic backup, point in time backup every day, and I can retain the backup along with the backup, and we can use the backup to restore the database whenever it is needed. All right. And we can set the backup window, right? I mean, whether we do have any preference, or if I have a customer sensitive or maybe workload sensitive database, right? I mean, I cannot take the outage whenever I need to provide a specific backup outage uh, where I cannot guarantee, like, you cannot take the backup at any time in a day. Rather, I mean, I'm having a workload sensitive uh, I am having the database with some sensitivity of workload, so I can specify the time and window when the backups can be taken. So I can provide the window where I can take the backup. And the backup replication is something like that. If you are having these backups to be replicated in different zone, then you can specify where you can replicate your backup, so that from that particular location, you can create a new database. Because if it is a new uh, region altogether, right now we are in North Virginia. So maybe we can say, like, I mean, I need a database to be replicated on, say, for say Oregon, and I can specify this replication during these backups. Whenever the backup will be taken, it will be replicated to Oregon. I can create a database from there as well. Or maybe disaster purpose, like, for example, I don't want to host a database all the time in Oregon, but I can create a database backup in Oregon, so that whenever there is any disaster happen, I can use that backup to create a database in the Oregon region without losing any data at that particular time when the backup was created. So this is all about this enable replication to another region. Right now, I'm not going to interested on that, but there is a retention period. You can specify the KMS key, because this KMS key is very important, because if you are having this encrypted database, now this particular we should have the decryption should be enabled to use in different region to use that encryption key. So all these things you need to specify if you want to replicate the database backup in a different AWS region. Now the next is encryption. Now definitely we need to keep the database to be encrypted at rest. So it should be protected. Uh, it should not be compromised during the rest. So we have enabled the encryption, but you need to provide the encryption key. For example, we are using the AWS RDS default KMS key, but you can definitely use different AWS KMS key, or you can create your custom KMS key and you can provide the KMS key over here. Now, you have the options to export the logs, like the audit logs, error logs, general logs, and query logs. So these logs will be actually exported to the CloudWatch. So you can have better visibility of these logs, like when the database was unavailable or what are the connections were made during this particular time. You can have all these details in CloudWatch log for your troubleshooting purpose. So it's recommended to export the logs to CloudWatch log, and you can specify what kind of logs you need to actually export. Similarly, you are having auto miner version upgrade. You can enable these auto miner version upgrade so that it will automatically upgrade whenever there is a minor version to be upgraded. Now, here a very crucial point in AWS RDS. It's a remarkable feature. So, if you are having a single zone database, for example, right now we are creating a multi AZ instance. We are not creating a multi-AZ cluster, but we are using the multi-AZ instance. So in this particular multi-AZ setup, we are having one primary database and as well as standby database. Now, whenever there is a patch will happen on primary database, uh, whether I can use the database to be read, because the standby database cannot be read, right? I mean, it is not being used for the read purpose. So this is not how RDS database actually patch the database. If you having this multi-AZ DB instance, and if you want to automatically patch the database, so what it will do, it will patch the standby database first. When the patching on the standby database completes, what it will do, it will switch the database. It will take over the database. It will fail over the database to the standby counterpart, and the standby database will become the primary one, having the new version installed in it. I mean, new patch, what is the patch you have applied at that time, it will automatically apply to the standby and it will become the primary at that moment. Once the failure will be done, then it will patch the database of the primary region and primary availability zone. And once the patching will be completed on the primary availability zone, again the takeover will be initiated and entire patching will be done with having microsecond level of outage, which is basically done when the failover will occur. Otherwise, there is no outage at all. I mean, from the application point of view, you will have very negligible kind of outage. And this particular feature you will have nowhere in Google Cloud, because this is a specific feature, the marvelous feature that has been provided by AWS. So whenever there is a patch will be performed, it will be performed on the standby replica, and the standby replica will be served as the primary one, and then the actual primary database will be patched so that you will not experience any kind of outage. For single DB instance, you will not have this feature because you don't have any standby at all, right? So how you can switch the standby to have the patch, right? So you cannot have these things. And the same thing is true for multi-AZ cluster. I mean, the standby servers or one of the replicas, one of the read replicas will be first patched, and then when the patching will be completed, then your primary will be served from the original primary one, and that will be patched. All right, so this is how the patching will be done in AWS RDS instances, and this is what we are going to choose over here. Like if you have any auto miner version upgrade, then just apply it automatically, and no need to worry about the outage because you are on the multi-AZ system. Now, you can specify the maintenance window, whether you can have any preference or not. For workload sensitive databases, we definitely choose the window like from when to when this maintenance can be performed. Like you need to specify some duration. Like, I mean, if this duration exhausts, then it will not patch or it will not do the maintenance. And it will choose some other window or other time when this maintenance can be done. And if you specify no preference, then it will normally choose the low usage time of the RDS database, and then it will do the maintenance. If you want to have the deletion protection, then it will restrict you to delete the database accidentally. So this is the extra protection of having the database to be deleted accidentally. So we have done with the form. We just click this create database to create the database for us. So let's wait for some time until this database is being created. Once the database will be created, I'll be back. So you can see that the database is right now being created. And once it is being created, we will just wait until it is done. After the creation will be done, it will start taking the backup of the same database. Once the database backup will be completed, then our database status will be available. So until that, let me pause my video. Once the database will be created, I will be back. So as I said, successfully database has been created right now. So if I refresh this page, it is right now configuring. So let's wait for some time. Once the configuration is done, I think we can able to use this database as well. So let's wait for some more time as well. So after configuring the database, right now it is being modified. So it will take some more time after these modifications. So I'm just trying to cover as much as possible the different status that it is being showing after we hit the create button. So after the modification will be done, I think the backup will be started. Okay, friends. So as you see, like, I mean, after the creation of the database, it just tried to modify the database configuration, and now it is in the backup state. So right now the backup is being taken. So once the backup will be taken, I think the database will be available for use. So just wait for some more time for completing this backup. All right, so finally our database is available and it is ready for use. So first and foremost things, let us see what are the things are there. So you can see the database is available state, and the database is MySQL database, and it is showing the percentage of CPU that is being used and the machine that is hosting the database, which is DBT3 Micro that we have chosen, and it is right now in US East 1B zone. Now you can see the security group that is default that we have mentioned, and we have the subnet group, VPC, everything that is there. Now we are having one endpoint. Now this endpoint we can use to directly connect to this database, and we are having the port number as well. Now, if you scroll below, you can see the security group rules that we are having uh, two security group rules, and this is a security group that we are having. And the outbound is completely open. So this is our security group, and we have the replication on, and this replication is basically to the sample DB. That is again, I mean, we have created these database as multi-AZ instance, so that's why replicated right now US Central East 1B. So we can click this replication instance as well, and we can see now if we go to this monitoring tab, we can see some CloudWatch monitoring with enhanced monitoring as we have uh, enabled, so we can see 1 second granularity, everything like a block, log, disk usage, CPU credit. So uh, everything we can see, like what are the possible instance we do have, and what are the things we can use. I mean, we can have the granularity like 1 second. So if I choose this period, we can go beyond 1 second because we are having enhanced monitoring enabled. So logs and events is something like that. One of the things we have done. So the last thing is the backup. So we have started with a creation of the database, and then it started to export the logs and then apply the modification. And once the modification is done, it started to enable these enhanced monitoring to 1 second, and then it started to take the backup. So all these operations are logged. You can see what are the events are done, and you can see the log streams are there. So you can have the details of logs from these log streams. So all these things are coming under the logs and events, and then the configuration. So all the configuration details you can see over there, and you can check what are the things we have actually mentioned. So you can see the multi-AZ is yes, and the secondary zone is US East 1A. So if we actually fail over the database from US Central Node 1B, which is currently being served for US Central 1, US East 1B, once we will do the failover, the failover will be done to US Central 1A. All right, so we are having the storage 20 GB, and we have selected the general purpose SSD GP2, and we don't have any zero ETL integration anyway. It's for the Postgre. So maintenance and backup, like we already have these backup, and this backup is available. So it was actually created during the creation of the database. We saw when the database was created. So we don't have any database migration, we don't have any tag. So all these things are there. Recommendations it will come whenever we will use the database more and more. So all these things we have checked. So now we are going to connect to the database. So let me close all these tabs for now, and let me go to this Cloud Shell. And once the Cloud Shell will be activated, we will connect to this Cloud Shell from a different window, maybe different tab, and maybe I can just have this closed. And once the Cloud Shell is activated, what we will do, we will check whether the MySQL client is installed or not. We can say MySQL version. We can see our MySQL client is already installed. So we can use this particular MySQL, and maybe I can just have the font a little bit bigger so that you can see it more uh, well. I mean, you can see it better. So what we will do, we will just click this, we just copy this endpoint, and we will provide the endpoint over here so that we can use the endpoint. And as we mentioned the admin as root, we can say -u root, and we can provide the password. So which is root 12345 6. We have provided the password, and let's see whether it can connect to the database. So you can see the database is not connectable. The reason because though we have mentioned the IP, we have mentioned that to have the public IP to be open, but if you see the security group, you can see the security group, it is not having the connection to be opened from the external world, right? So what it has having right now, it can access, it can let me open the security group, and then we will see what the security group details are. So we can see it is having the inbound rule. So let me edit the inbound rule. Now it is having the security group to access this traffic. So if we add another rule, and if we say all the TCP IP, and if we say anywhere, from anywhere it can, this particular database can be accessed, then only the inbound rule will be opened to the external world. It's still trying to connect to the database, but let me save this one. Once I have saved this one, uh, it can able to connect right now because it is having opened for external world. So if you see that this particular security group having the internal inbound rule, which will accept all the traffic from anywhere to any port. So this particular security group rule is been added. Now, if I cancel this one and if I go ahead and try to establish the connect one more time, this time you can see immediately it got the connection. It got connected. Now, if we check the databases, what are the databases we do have? You can remember that we provided one database named as TasteDB during creation of the database. So it will show the TasteDB is there. But we can connect to this TasteDB, but you can see that we are connected to TasteDB, but this particular TasteDB does not have any table. So what we will do, we will create a couple of tables and table spaces, and we'll see how we can use this particular table, use this particular database to create the table space. Now, for now, let us create one table space. So for that, I'm just going to create a table space TS1, and let me paste that, and you can see that we have the access denied. You have at least one table space privilege for this operation. So here, actually, we cannot create the table space until we have the access to create the table space inside the database. So we will come across all these things when we are having these uh, permissions with us. Now, if I try to provide, if we try to create the table, if we try to create table, say for example, employee, and we can say like name as character 50 as the column, and ID, which is integer, and if we press enter, we can see that we are having the table got created. Now we can insert one data into this particular table, insert table employee, and we can say values like John, and we can say 40 is ID. The data will be inserted over there. Similarly, we can say Harry, and we can specify um, the name as Harry, and we can try to check the table. Select asterisk from employee. We can see the data is inserted successfully. Now we have created the RDS database. In this particular video, we saw how we can access this database from the outside world, though we have provided the IP address to be created for the public IP address to be created for accessing this database from the outside world, but that was not sufficient. We have provided the network access from the security group level of that particular VPC. Then only we are able to connect to the database. So this particular video was dedicated for creating the RDS database. So in the upcoming lecture, we will see how we can play around more with this RDS MySQL database. But in this video, before we leave this particular session, we will show you how we can fail over the database from US East 1B to US East 1A, because right now the database is a multi-AZ database, and right now the region is US East 1B, and this particular multi-AZ database, we saw that particular database is having a standby replica on standby instance on US East 1A. So thanks for watching this excellent demo. So we have covered how we can create the RDS database and RDS MySQL database. So this is the first video in this series. So in the subsequent lecture, we will see how we can failover the database to the other region, how we can create the RDS replication. We will create the read replica of the database, as well as we will see how we can use the same RDS database to have the RDS Aurora counterpart of it. We can create the Aurora application as well integrated with this RDS database, and how we can promote that to a standalone database to migrate it to our Aurora system. So we will slowly deep into these things, and we will create the Aurora database as well, and we will see different RDS flavors, how we can use this database to have our database hosted on AWS system. Thanks for watching this video, and we will see you in the next exciting video very soon. Till then, goodbye. Thank you. Have a nice day.